This isn't a normal speaker. This guy is one of the pioneers of the internet. He was one of the guys that took AOL from 2 billion to 220 billion. He is one of the top venture capitalists in Silicon Valley. Ladies and gentlemen, join me in welcoming Barry Schuler.
Can we get a little, there we go. So this is going to be a little bit different because we're going to talk about technology, but it's the technology of life. So I don't know if you know it or not, but while you've been busy Snapchatting and thinking about the next great app, scientists and technologists have been figuring out the code of life. And it's going to change everything. So let's rock and roll. I like to point this out. I don't think anyone here was born in the year 2000, but you probably know somebody. And if you were born, for the generation that was born in the year 2000, they're a generation of firsts and lasts. I like to point out they're probably the last generation that will ever drive a car themselves. And thank goodness, because as I said yesterday, humans are awful drivers, and as soon as we have our cars as robots, a lot of people won't die on the road. They will be the first generation that probably is not going to die of cancer. Maybe in 10 years, no one will die of cancer. And they will be the first generation that routinely lives to triple-digit years, whether that's 100 or 200 or maybe more, we don't quite know yet. It will also be the last generation to eat seafood unless they go and actually catch it on their own. We're going to talk about that in a little bit. And they will be the last generation that witnessed starvation. So why do I say these things? As I mentioned, we're in the midst of the most profound period of discovery and invention in the history of humankind. It sounds like, well, you were a computer guy. Wasn't it a big deal when the microcomputer came along? Yeah, it was pretty good. And computers are good, and your cell phone is good, but what happens when all of a sudden we have the code of life, and we understand what it means? And not only do we understand what the code of life means by reading it, but we can write it and change it as well. This all started in the year 2000 when the first human genome was sequenced. Now, the genome is the code of life. You know, you get a big list of a bunch of letters if you remember your high school biology. And when we sequence a genome, we get all that code, but we don't necessarily understand what it means. It's like if someone handed you the code for Microsoft Windows. You'd look at it, and you know, if you're a coder, you could figure it out. And by the way, it says 13 years. It actually took all of humankind's combined intelligence and technology to get to that point, and about $3 billion to sequence one human genome, Craig Venter's. Today, a short period later, it's $1,000 and going down fast and can be done in a day or so. So now that we have this code, and by the way, it's much easier to sequence the genome of a bacteria or a plant. I live on a vineyard in Napa. I grow wine. We're certainly interested in our grapes' genomes. And so what's happening is there's an explosion of sequencing of all living things right now. And it's being reposited, it's being shared. And all of a sudden, biology starts to look like big data. So technologists and biologists can get together. But genomes don't behave exactly like computer code. So if you look at this simple equation, 1 + 1 = 2. 1 + 1 will always equal 2, no matter what you do. But when you're dealing with living organisms, and you say, I have a red carnation and I have a white carnation, and I'd like to get a pink one, so maybe I'll put them together and they can get cozy, cross-pollinate, and I will get a pink carnation. But when you actually do that, sometimes this happens. And sometimes this happens. So it's not exactly like the 1 + 1 = 2 all the time. In fact, life is very dynamic and changing all the time. But now that we can read the code, we can understand why that happens. And when you understand why that happens, you can have impact and effect on it. You can control what it is. So why do we care? Well, I'm going to, I've tried to skew this toward food because this is a food session, but everything that's going on in genomics is going to impact medicine. It's going to impact manufacturing. It truly is. We'll look back on at the year 2000, sort of like the book, that this was a year that began the next era of humankind. So think about the ability to make fuel, petrochemicals, although buy electric cars. We're investors in Tesla. Forget about the petrochemicals. Making fuel like we make wine, brewing it with algae or bacteria. Imagine the ability to fabricate proteins by 3D printing them with a 3D printing-like device. Think about crops, new generations of crops that can produce high yields, grow in very difficult environments, sub-Saharan environments, Saharan environments. Imagine completely disrupting our relationship with disease. We live in fear of getting cancer, heart disease, many horrible things that we've not understood, but at the genetic level we can start to understand what's really happening and how we might cure. And we can end starvation, and we can actually repair the ecosystem. One of the things you hear, people are very scared about GMOs, and it is kind of scary when you talk about manipulating life, but some of the problems that we've created, like too much carbon dioxide in the atmosphere, we could also use this technology and knowledge to repair and also have more respect and treat our ecosystem better. By the way, this is not new. People have been messing around with genomes forever. The Romans bred dogs for hunting. They've been cultivating, the Native Americans cultivated corn. Those guys gave Christopher Columbus a little dose of popcorn when he was there. If you have a dog, there's no dog or cat that's domesticated that isn't heavily GMO'd, meaning they wouldn't exist in nature. We did it by breeding. But we've also developed that technology over time. And you should know that the things we do in the environment also modify genomes. So, for example, when you take antibiotics, you're modifying the genome of the creatures, the little bugs you're trying to kill with antibiotics, and they change. When we fertilize the soil, when we use insecticides, we cause mutations that actually engineer the crops and the food around us. And then we've learned how to mess around with genomes. You see this little glowing kitty. It looks like, oh, isn't that a joke? Somebody took a cat and they, crossbred it with a glowing squid. Actually, these bioluminescent cats were done to create tracers to help cure AIDS. And it was how they were able to learn the mechanism behind HIV. And that's been done with gene splicing or recombinant DNA. And then, of course, we hear about GMO foods that have been bred for shipping or to be insect resistant. And it's very controversial. People worry about what they eat. And you should worry. And the reason they worry is because we don't fully understand what we're doing when we're just tinkering around with genes. However, if we have the whole code, if you have the whole instruction book of how the species works, you're not playing anymore. You know exactly what to do. And this leads me to another profound discovery that has gone on, and I expect we'll be reading some really interesting announcements this year, and that is life has been created in the lab. In 2010, Craig Venter's group, same team, took a very simple organism and they looked at its genome and they fabricated it from scratch. They used a computer and they replicated its genome and they added some things in, little watermarks, people's names, so that if it worked and the species replicated, you could see it in their DNA. And then they took natural organism, they took its DNA out, they put the artificial one in, and what do you think happened? Did they have to shock it like Frankenstein? Did they have to call God or the Force? No, actually, it just booted up and went because nature is very powerful. And we're starting to understand nature's toolbox. So that was a stepping stone to the next step, which is actually create an organism from scratch. So when you're dealing with, a human has about 30,000 genes. Pretty complicated. These are very simple creatures with 550 or 80. You can really understand what they all do. So they set about creating an organism from scratch that doesn't exist in nature. And watch the news and you'll find out whether it actually worked or not. But presuming it has, it tells us we now have the ability to write the code of life in the same way we might write a computer program or design something to do things we want them to do. And this will revolutionize everything. So this ability to either create life or by sequencing genomes, finding forms of life that do things we want them to do really forms the basis of this revolution that's happening. Nature is very powerful. Trees make turpentine. We find oil, which is really, fossilized algae. Nature out-engineers us by far, mostly because nature doesn't have to ship a product next month to stay in business. Nature has had millions and millions of years to evolve slowly and get it right. And the toolbox is very powerful. And we can harness that toolbox for growing food, for medicine, for manufacturing. And the other thing is that once we have a genome, it's digital. We can send a file just like you send an email. In fact, you've been reading about finding water on Mars, yeah? People are excited. If you find water, there's probably life there, and they want to go and see what's there. Well, if we went to Mars with a robot, which we will, and we go digging around for microbial life, we don't have to package it and send it back to Earth and hope it's still alive. All we have to do is send a robot with a gene sequencer, assuming it has DNA, by the way, but sequence its genome, send it home electronically the same way you get online, and then we can take that code and replicate that species right here in the lab. I'm sure they'll keep it locked up till they figure out what the heck it is. The point is, when you think about this as it relates to food, how we grow crops, how we look at food production is going to completely change, and it's already starting to happen. So I'm going to go through some of the things that are happening. You may have heard about algae as it relates to fuel. Algae is a very powerful little creature. It's pervasive. It is where all of our fossil petrochemicals come from. They happen to be very good at storing fat, just like me. And some are better than others, and by finding natural algae, by sequencing their genome, or if you want to go ahead, engineering them, or building a form of algae from scratch with all the tools they have, all of a sudden you may be able to make cost-effective fuels for cars. They're already making all kinds of foods. So there are several companies that make algae-based oil that's healthy, very low in cholesterol. Protein is harvested, fats are harvested, omega-3 fatty acids, fish oil that you may take as a supplement without tasting fishy. And in fact, you can pretty much do anything in the petrochemical chain. So there are companies looking at using algae secreted products to make plastics, eco-friendly plastics that are recyclable. This is one of my favorites. I don't know if there are any vegetarians or vegans here, but generally they say they don't want to eat anything that has a mother. And of course, ranching and livestock and deforestation has profound impact on our environment. So a lot of people have been looking at not a meat substitute. We all can go and buy those soybean hamburgers or taco meat, which tastes not exactly like meat, maybe not a satisfying replacement. But people are looking at, can we just grow the muscle tissue that's a part of steak or chicken breast or whatever? And the answer is, of course you can. All you have to do is harvest some of the tissue, give it a few instructions to say, grow without being attached to something, and get it to grow fast enough, and all of a sudden you'll have motherless meat. So the amount of motherless meat that has been made is small and expensive, but you got to start somewhere, right? And there are people who are also looking at, again, 3D printing protein structures in the form of the kinds of foods we like. At the same time, protein powders are very easy, and there is a protein shortage in the world. There's a starvation problem in the world. The ability to produce these things, put printing machines or protein fabrication machines in areas where people are short of food and create protein products there rather than trying to ship them across the world is what's going to help us solve starvation, along with the ability to get crops there that are tolerant to their climates and produce a lot of food for people. This is a really interesting area. Has anyone heard of this word microbiome is popping up now and then? A couple of hands here. So microbiome is a very interesting discovery, and the discovery is we are not alone. We're actually a colony. I'm going to talk about the human microbiome, but in plants, what we've discovered is in the root systems of plants, there are all kinds of bacteria. And those bacteria eat the compounds in the soil, and they poop it out, and that's what the plant ingests. And it's those chemicals, those biochemicals, that really impact the fruit that comes out of the plant. We're very interested in this in grape farming because we want to know what is it that gives our grapes good tastes and bad tastes. And look, people have been fertilizing, farmers have been fertilizing for a long time just because they knew that it did something. Well, what they're really doing is feeding the microbiome, which is feeding the plant. When it comes to humans, we have a microbiome too. Turns out a lot. Turns out that we have 90% of the DNA in your body is not yours. A guy like me, a pretty big guy, has 20 pounds of various bacteria, flora, and fauna in my body, on my skin. And this is a colony that we live together with. We need them. They help us digest food. They help us regulate a variety of things. And inadvertently, when we've been taking antibiotics because we get a cold or a flu, we're killing our microbiome. Also, when we eat yogurt and it makes us feel good, we didn't really know what we're doing is feeding that microbiome. When we talk about healthy eating, it's our microbiome that we're affecting. And this is one of the biggest areas of research because it's turning out they believe a lot of stubborn diseases may be being caused by some imbalance or the wrong kinds of bugs getting into our microbiome. And this is a very exciting area of food where food manufacturers are looking at how do they not just create food that tastes good, but feed our microbiome and help us attain the kind of balance that we want. And so you're going to be hearing a lot about probiotic foods and nutraceuticals. This is really fast to do in 20 minutes. I'm down to 2, but I'm going to get there. Another area is aquaculture. You may have, I mentioned before, that this generation is likely to mostly be eating farmed fish. It's because we have so voraciously depleted our ocean's resources, we're not going to be able to have enough fish. So there have been enterprising people who have been farming fish, but there have been problems. One of the problems is you need 3 to 5 pounds of fish food to get 1 pound of protein back, which means you got to go catch little bait fish, grind them up, throw it in there. And it turns out where they catch the bait fish are in areas that are pretty polluted around the world. And when they grind it up and they concentrate it, so when they feed the farmed fish, those farmed fish end up with toxins in them, which has been a real problem in the first generation of aquaculture. Well, now that they've sorted that out, they're looking at new ways to feed them, and we can go back to our friends algae, one of their natural foods, and cultivate algae and pick strains by understanding their sequence that are fast-growing and make a viable fish food, and all of a sudden aquaculture becomes healthier and better. And at the same time, they are engineering fish species. One was approved in the US, a salmon that grows much faster on much less food. People are a little spooked about it, but if you can read the genome of that fish and you know there's nothing there, it looks just like a natural fish, you're not acting from ignorance. All of the fear of GMO comes from ignorance, and it's okay. Trust me. I'd eat a GMO to anything that's been approved probably more easily than take all the antibiotics they throw at you when you get a little sniffle. So where are we? We are right at the beginning of this revolution. There's amazing things going on. There are tools being developed, there are products coming out, there are companies being formed, and because this is a combination of biology and IT, big data, what you see happening is the world is getting together and working together in a crowdsourcing way because, you know, we hope we're going to cure diseases and end starvation and make good things happen. There is a dark side to all this. Last slide, don't worry over there. I see them pacing around. There is a dark side to this, like there is with any technology. I mean, when electricity was discovered and put to work, it could shock you. When we were developing nuclear technology, they were afraid they were going to blow up the planet. We're sort of keeping that one a little under control. It's very important with all technologies, and we certainly see with the internet, it delivers lots of things, but there are hackers and bad people out there. The key is responsible management of innovation, the community getting together and creating standards for everybody. Thank you very much.